Hi everybody, this is Chapter 1, Section 3, Particles of Matter. The vocabulary words associated with this section are atom, which is the smallest particle of an element, molecule, which is a combination of two or more atoms, and chemical bond, which is the force that holds two atoms together. This section focuses on atoms, and atoms are the smallest particles of an element. And everything on Earth is made up of these atoms. And we talked a little bit about the periodic table of elements. And on that periodic table there are about 118 different elements. Now we're going to investigate almost all of them. The first person who ever came up with the idea of atoms was Democritus. And Democritus was a Greek philosopher who lived a very long time ago in about 440 BC. And his job as a philosopher was to just go around thinking of things. And one of the things he thought about was the smallest particles that make up an object. And he called these particles atomos, which really is Greek for uncuttable. And he didn't have any way to prove his theory or his ideas of atoms, but later on, other scientists look at Democritus' ideas and base their experiments on his ideas of atoms. One scientist who looked at Democritus' ideas of atoms was John Dalton. And John Dalton was a British school teacher. He lived at about the 1800s. And he looked at Dalton's theory of atoms, and he performed experiments. And he was the first one to perform experiments to prove his theories of atoms. You have to remember that back in 1802, they didn't have the equipment that we have today to study atoms. So he was basically using very simple tools to study particles that you can't see without a microscope, a very special microscope. So the fact that he came up with his atomic theory is really remarkable. Here are some of the main ideas of Dalton's atomic theory. First, he thought that atoms could not be broken down into smaller pieces. Dalton really thought that atoms were hard, very, very tiny marble-like structures that could not be broken down. We now know that atoms are actually made of smaller particles called protons, neutrons, and electrons. Dalton also thought that in any element, all of the atoms are exactly alike. That means that if you looked at an atom of hydrogen, it would look like any other hydrogen atom on Earth, or in space for that matter. If you looked at any other gold atom, it would look like all the other gold atoms in the world. And the same thing for all of the other atoms on the periodic table. Dalton also knew that atoms of different elements were different. So if you looked at a hydrogen atom and you looked at a gold atom together, they would look very different. You would be able to see a different number of protons, a different number of neutrons, and a different number of electrons. And remember still that he did not have the equipment to see those particles. So all of his ideas were based on guesses, or we call them in science inferences, based on his experiments. Here we're continuing on with some more of Dalton's ideas. So we have two or more elements can combine to form compounds. And we know this, we've discussed this in class, that if I take hydrogen atoms and oxygen atom and I combine them, I would create a compound, and that would be water. Dalton also knew that all the atoms had different masses from one another. So if you looked at the mass of neon up in the left-hand corner here, you see the number 20.18. That is the mass, the average mass of one atom of neon. And finally, Dalton knew that if you are creating a compound, that the masses of the elements in that compound are always in a constant ratio. So if, again, we go back to our water molecule, we know that the ratio of hydrogen atoms to oxygen atoms is 2 to 1. 2 hydrogens for every 1 oxygen. And that's true for every molecule of water you will find everywhere in the world. So that's where we get the constant ratio. As I said earlier, we have groups of atoms that can combine to form molecules. So right here, that little group of atoms right there, the 2 hydrogen and 1 oxygen, that creates a water molecule. But if we group together those molecules in a bigger group, we call those compounds. And the force that holds these atoms and compounds together are chemical bonds. So we have a chemical bond right here and a chemical bond right here. All the bonds that hold the atoms together are chemical bonds. We know that atoms are small. For example, we have about 2 billion atoms of oxygen in just one tiny drop of water. That's really small. So how do scientists see them? How do we know that they're there? We have instruments called electron tunneling microscopes, and they allow scientists to see into an atom, to see the particles that make up the nucleus, and to see the smallest particles that make up the outside of the atom, which are the electrons. The electrons are the smallest particles of an atom, and they go around the nucleus. And there are some of these types of microscopes here in Massachusetts. They have some in Harvard University and some other colleges as well. And these are humongous microscopes, not like the ones you may use in your science classes. These are huge, 2 to 3 story tall microscopes, and they're powerful. They are so powerful that they are helping scientists understand how these particles behave and why they bond the way they do. It's pretty cool stuff. Before you come to class, take the time to go back and review Dalton's 6 ideas about atoms, his atomic theory, which we will discuss more in class. I'll see you soon.